I actually had a question for 65F. Is it basically asking for like the space in between like the first quartile and the third quartile?
Yes. It's actually not asking, they're kind of being silly. They say they want the interquartile range, but what they really want is the first quartile and the third quartile. The interquartile range would be the actual number you get when you subtract those two things. So figure out what Q1 is and figure out what Q3 is. And that's what you would put down. It looks like on part E, you already figured out the first quartile, right? So all you got to do is figure out the third quartile and you got it. Does that make sense?
Yeah, that's what I thought. Thank you.
You're welcome. So just to say this one more time, all the quizzes have been graded. So if you haven't looked at that yet, take a look. If you have a question from the quiz, let me know. If you have a question from homework, let me know. Give you a little bit to think about that.
I have a question on the quiz.
Sure.
So for some reason during the
Uh-oh. Are you still there?
or one of those, please.
Rhiannon, are you okay? I can hear it. Oh.
Can you hear me?
Now I can.
Oh, I completely forgot how to do the first three. Could you go over one of those? For some reason I remember how to do the rest of it. I couldn't figure out those.
Oh, the one about the uniform distribution. Right, I guess. The one about the auto repair shop.
Let me check really fast.
All right. Oh, all right. Yeah, I was wondering about that. Let me see. Somebody's sending me a private message. Sorry.
Yeah, for the uniform distribution.
I'm sorry. Hold on. All right. Let me see. Oh, yeah. So what does the uniform distribution look like? Anybody or Rhiannon, either way.
Looks like a box.
Rectangle.
Yeah, big old box, right? And there were several different versions of the quiz. So let me just do an example that nobody had, but everybody had. So if I had, let me see, sorry. I can't see, there I am. Hey, me. All right, straighten my house out, okay. So if I got a uniform from 5 to 19. So really, the only thing I have to figure out is what the height is. So way too many people, when I say way too many, maybe about 5, did a uniform curve for number 1. No, normal. It is a uniform, not a normal. So no Z scores here, none of that. Right? So how tall would this one be?
1 out of 14.
All right. And then any question I ask you, so that'll be part A. Part B, if I say what's probability that it's from 9 to 13, I just got to find the area of that, which would be 4 times 114. Which is like, what is that, Jeff? 0.28 something or other, maybe? I don't know. Just making that up. Does it sound good? Is that all right?
Yeah, thank you.
You're welcome. So that goes for a few other people. So number one, there was no normal curve. Number one, there's no z-score chart to use. It's a uniform distribution. Let me think, what was the other? I don't think there's any other like major mistake that people had in common. You all had very unique mistakes you made. Overall, it was really well done. Like normal, it's either you get this or you completely don't. So there were 90s and 100s, and then there were a few 40s and 50s. So not very many grades in the middle. There are a few 101s, which is nice. Okay. Anything else, guys? Anything else from the quiz or from homework? Okay. Did I answer the bonus? No. Oh. Several people got the bonus correct. So depending, so if your number 3A said, so let's make, so let me talk about the bonus. If you did 3A, let's say my number 3 was about heights of Finnish. Did anybody have Finnish men? I don't think so. Finnish men. So some people had Nepalese, people from Nepal. Some people had, I can't remember, Austrian dudes and whatever. So if I got the probability that a Finnish man was less than 72 inches tall, and I got like who cares, 0.4197. All right, so let's say I got that for part 3A. The bonus would have been 41.97% of Finnish men are below 72 inches tall. Bam. That is the interpretation. Is that cool? Oh, what is that? Oh, I love that. Somebody's asking me about P tiny number. I love it. So I know what you mean. You can't forget stuff we learned before. So what does something like this mean? What does that mean?
The 11th percentile.
Yeah, this is the 11th percentile. I don't know if you guys ever saw an equality with 3 signs. This means it's defined. This is defined to be this. So if I were to draw that, where would the 11th percentile be? Down here, because there's supposed to only be 11%. And then I can find the z-score, and I can make that into an x-score, blah, 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 blah. Is that all right? Yes, no, maybe so? Okay. No, I'm not being, what do you mean? That's a real thing. So a triple equal sign means like defined to be. So do I have resting sarcastic voice today? I don't know. Somebody was asking me if I was being sarcastic. That's all right. Yeah, that's not something that students normally hear about or see is the triple equal sign, but that's what that means. And you're all like, I'm really happy. I know that now, Mr. Waller. That's okay. So glad you told me about that, Mr. Waller. Okay. Anything else, guys, before we get back into? We're gonna actually get back into new stuff, I guess. We're gonna start some new stuff today.
I have a question.
Yes.
I think it was the uniform distribution for the third question, I believe. It was like find the area from 1 through 6. Would you have done 6 minus 1 to have gotten -5?
Well, no, that would have been 5, but no, The bigger answer is no, because let's say I can't remember, what was the one I just did? I don't remember. So let's say I have 9 to 16. So how tall would that be? 1/7. So if I want to know the probability that 5 is less than X is less than 10. This is the reality. This is reality right here, right? It goes from 9 to 16. That is reality. If I ask a question about reality, reality doesn't change. I love saying that. I've never said it that way before, but that's what it is, right? You don't say, why is the sky blue and it suddenly turns plaid, right? They've gone plaid. No, it doesn't happen.
Okay.
So here's the thing. And if I'm you, I would say, all right, that's great, Mr. Waller. It doesn't really answer my question, but it's a good idea you didn't take that tone. 5, where do things kick in? Not at 5. 5's got no height. 6 has got no height. 7's got no height. 8's got no height. It starts at 9. So, and I want to go up to 10. So now I just find the area of that. You don't suddenly extend or something. You can't suddenly say, now you exist things that don't exist. You can't do that, yeah. Okay.
Okay, I understand.
I like it. Thank you. And again, I'm not trying to be whatever. I just want you to realize what it means. So a lot of people did that. A lot of people like extended this. What you're doing is you're bringing into existence things that don't exist in that problem. That's some freaky high level shit. It's like omni-mutant stuff. Don't be doing that. It's freaking me out. Anything else, guys? Anything else from the quiz or from homework?
I was just wondering, like for 65, I'm a little bit confused by the wording of the question of like, I don't understand like how we get the standard deviation.
Are we still talking about the length of songs?
Yeah, this is the length of songs.
Okay. And what's N in this problem?
The 43?
No. Well, let me see. Let me make sure I'm talking. Yes, you're right. Okay, I'm sorry. My eyes wandered. So N is 43. It's uniformly, I love 65. I love the hell out of 65. Let me share this with you guys so you all see what I'm talking about. 65 is a uniform distribution, right? From 2 to 3.5. Can you figure out what the mean and the standard deviation for that uniform curve is? In fact, we'll just do this. I'll give you, I'll switch in a minute. Hold on. I'm letting you see that problem. Right, number 65. So let me come up to the board here. Pow! So they tell me it's uniform from 2 to 3.5. Can you figure out what's the mean and the standard deviation for that uniform distribution? Remember these?
Mean is like 2.75, right?
Yeah. So if you do this 5.5 divided by 2, you get 2.75. I like it. And the standard deviation? I think it's about like 0.4.
0.066.
Oh, I was way off. What am I trying to do? I'm trying to do too much in my head. What do you get? 0.066? I'm curious now. Oh, I see what it is. No, I don't see what it is.
That standard
No.
deviation should be 0.433.
Yeah, 0.433. I'm not sure what happened here. It would be the square root of 3.5 minus 2 over 12. 0.433. So that is this standard deviation, and that is the mean up here, right? Okay, stay with me, everybody with me. I know I didn't make a big deal out of these formulas. They're just stupid little formulas. You just got to plug A and B into them. Not that big of a deal, right? But the point of this problem is we take 43 songs, right? Let me bring this back. And they ask about the sample mean. So to fill this in, part D, and then to do part E and part F, I've got to figure out what the new standard deviation is. Because I'm taking a sample of 43 songs, right? So the standard deviation's got to change. And it was uniform, but what's it going to be now? When I take the 43 songs, what's it going to be?
Normal.
Normal, because that's greater than 30. So what's the new standard deviation going to be? It's going to be the old one
Right.
divided by the square root
Of the sample size. So 43.
yeah, whatever that is. I like it. So that problem really,
0.066.
that's so somebody else was ahead of me. Okay. I wasn't there yet. Whoever said 0.066 earlier. The reason I love this problem is because no matter where the standard deviation comes from, if I then take a sample from my population, I've got to change it, no matter where the hell it came from. If I just told it to you, or if you calculated it, or whatever. That's the point of chapter 7. Okay. Oh, no. Somebody's asking me. I love it. You guys just can't get enough of this triple equal sign. I would think no. I would think that you would never use it. But you can look it up. Whatever you like. All right. How are we doing out there? Anything else?
Well, for the same exercise, can we do E or F for the
Oh,
exercise
okay.
that we were doing?
So now let me see. Let me put this, the mean.
Yeah.
And the standard deviation I'll put over there. What was it? 0.066? Is that right? It was? I think somebody said that.
Yes.
Yes. Okay. Thank you. So part E wants you to find the first quartile, right? If I remember correctly.
Yes.
And we know it's normally distributed now because n is greater than 30.
Mm-hmm.
So I'm trying, where's the first quartile on the picture?
To the left of the mean.
Yes, because there's only going to be how much in here?
0.25.
I love it. So can you find the z-score that goes with this?
Minus, well, 0.67.
I like it. I always found this to be interesting. Let's see if anybody else finds this to be interesting. If I go 2/3 of a step down, I'm left with 1/4 of the picture below it. I just like the way those numbers go together. That's 2/3 roughly, right? 2/3 is 0.666. And there's 1/4 of the whole picture below 2/3 of a step down. Anyway, enough. I'm sorry. Enough of that. So yeah, now you just got to change this into a song length. And using this formula, it changes the z-score back into a raw score. So this formula changes a raw score into a z-score. That formula changes the z-score back into a raw score. Just got to plug that number in. Sorry. Oh man, will the triple equal sign die? No, it won't. Somebody's asking me to make it a bonus question. I love it. They're all fascinating. I love how you pick stuff to focus on. Is that all right? Is that all right?
Yes, thank you. And then for F, it will be the same, but positive, right?
Yeah, all you have to do is figure out what Q3 is. So that'll be 25%, and you need to know what that is so you can find out what the z-score is, so you can plug it in here to figure out what the x.
Thank you.
You're welcome. Okay. Let's see. I have somebody else sending me a question. Whoa. Okay. Let me see. Give me a minute here. Oh, all right. Yeah, person that just sent that question to me about quiz number 3D, you have the wrong z-score, that's all. I understand where you got what you wrote, but just really, really be careful with what you find on the z-score chart. You don't get what you thought you got. It's close, you're just missing a number. Okay. Anything else, guys? Okay, so what we learned in the last chapter was when I have a sample greater than 30, then the sample means will be normally distributed. And the mean stays the same while the standard deviation gets small. All right, that summarizes everything we learned in chapter 7. So the mean stays the same, but the standard deviation will get smaller. And we saw examples of why that makes sense, why the whole thing is going to shrink in on itself. Okay, I like it. So what we're about to do, there was actually a problem that kind of prepped us for what we're going to do today. And it's always interesting to me which way I choose to do this, to introduce this subject. There's just multiple ways to teach this kind of stuff. So this formula here is interesting. We're going to use this bad boy, but let me do it this way. There was a problem. I think was it on the practice quiz? Let me look it up real quick. I think it was on the practice quiz. Get out of here. Where are you? Get over there. Is that where I put it? There you are, practice quiz. Come here. Come here. Come here. Okay. All right, I'm gonna, yeah, this is it. Yeah. No, it wasn't here. It's not the one I want. Man, all right. I can't remember where I put this thing. So let's make a new problem. All right. So let's say I have a group of data. I'm gonna be really boring, I don't care. The mean is 29 and the standard deviation is 4.7. And I take a sample of 33 data points. Between what two numbers would we find 90% of the data points, of the sample means? There we go. All right, let me let you guys copy that, and let me let you wonder what the hell that means. This sounds vaguely familiar. It's that problem there. It said bounding the middle whatever percent. Remember that? Somebody had an issue with the word bounding and what the hell that meant. So am I talking about sample means? Yes. Did I take a sample? Yes. So what's got to happen first?
The standard deviation has to change.
Standard deviation has to change. Let's do that first. Okay, I don't know. All right. So it's going to be what it used to be divided by the square root of Larry Bird. 33. All right. Stop for a minute. Okay, now I can you find the z-scores that catch the middle 90%? Can you find what these z-scores would be? Go ahead. No, what?
Like 5 to the left and 5 to the right.
I like it. So there's 5% here and 5% there. Who cares about that? If I know there's 5% here, can you find that z-score now? I couldn't use this number for anything, but the chart understands this number. Is everybody cool? There's 5% out here, obviously, if there's 90% inside. So can you look up that z-score right there? It's going to be that special situation.
Negative
Isn't it-
1.645.
Go. So then what's this one going to be?
Just positive 1.645.
I love it because it's symmetry. Now, I need to make both of these z-scores into data points, into normal data, back into x-scores. So don't I have to do this formula for both? But what's going to change with that formula? So if I want to use that formula, I can't do this. What has to go there instead? I can't use this because I'm talking about groups of 33. So what's supposed to be here?
The new standard deviation.
Yes. So let me put the new standard deviation here. So instead of that, I need to use this. Because I've taken a sample, I'm talking about sample means I got to chase standard deviation, which we already did, but it's okay. And then the z is still there. And I might as well, don't I have to do a positive z and a negative z? So why don't I just do this? I don't know if you guys remember, we did do this somewhere. I can't remember what worksheet it was on. So now I can throw all my stuff in here. The mean is 29, give or take 1.645 times the new standard deviation, which we already calculated is 0.818. All right, let me stop for a minute. Everybody doing all right out there?
I was just wondering, so for like the new standard deviation, how should we refer to it more formally if we're in like writing a sentence?
So it's the standard deviation for the sampling means. In the notation, it's the standard deviation, that's this piece. It's the standard deviation of the sample means. So now you see why I gave it a shorter phrase to reference. But I like that. It's a beautiful question. It's not the formal name of it. That's the formal name, that long ass name.
Got it. Thank you.
And I really want this to make sense. I'm not talking about individuals now. I'm talking about groups. I need to know how the groups are distributed. So that is the standard deviation of the means of groups. So that's why that's the number I use. It's how spread out the groups are. So kind of, I'm hoping this makes sense on one level at least, that if I go at 29 and I go up some and I go down some, I'm going to catch 90%. So I'm just curious, how much up and how much down do I have to go? And that's what this work is. I've got to go up and down 1.645 steps. And then this step is do that. So if I write this slightly different shade of blue here. So if I got 29, give or take, what's 1.645 times 0.818, 1.345, so 1.3456. Is that one? That's a neat number. I like that. So then I can do 29 minus this and 29 plus this. Pretty cool with what happened there. So why is there a plus or minus here? Because I want to go up and down this much. That's why I put a plus or minus there. So now I just do 29 minus this and 29 plus this, and I can see my interval. I can see what this is, what this is. So let's see, I get 27.65 up to 30.35. All right, so this is still chapter 7. This is not chapter 8 yet, but chapter 8 is one little step away from this. So I'm going to take this away, all except for this guy. So all we did was we figured out we had to go this far above the mean and this far below the mean. All this step down here is doing that. Go up this far from the mean and go down this far from the mean. It's just I had to use the right spread. I had to use the spread that worked for groups of 33. All right. All right, let me put that up here. So this is an interesting. So chapter 8 is where we take our first step into more of the real world. Section 8.1 is a tiny little step. All right. Let me set up an example here. Let me see. I can't get away from that example. I don't want to do the exact example because it's on the handout. I want to do a different one. All right, here we go. Let's say we're curious about, we find this island somewhere and we find these people living on the island and they are horribly misformed. This guy is sitting down. Don't worry about him. They look like flowers. So leave them alone. And I'm curious I'm curious about what their average height is. And I know the standard deviation for all heights of all humans. Let's say I know that somehow. All right, just go with me. I know the standard deviation of all humans is 2.98, let's just say, for the humans' heights. Okay. So what I want to do, let's see, how can I explain this? If I take a sample of these people, because there's quite a few of these people living. This is kind of a big island, so there's quite a few of these people living. Let me demonstrate that by drawing a few more of these unfortunate souls. Right? They're all living. There's more than 4. There's each one of these represents 10,000, whatever. So I'm going to take a sample of these people. And do I know what this is for them? Do I know what this is? What does that symbol mean again?
Population.
Population mean. Even after I do my analysis, I am not going to know what that is. What I'm trying to do is to get a feel for what that might be. So a sample mean is the first step in that direction, but it's not good enough by itself. So let's say I take a sample of 189 people from this island. And I find a sample mean height of, do it, Jeff, put it down, make it up. There it is, certainly, sure, okay. All right, sorry. I don't know why I always have to do this on the fly. Why can't I just do this ahead of time? But too bad, you get to experience. Do it live. So I don't know this. This is my best guess for this. But how far off am I? So this is what this thing we're going to create will try to do. So let me say it like this. Since this is 189, what do I know is true if I plotted all the sample means? What would it end up looking like? Sample size. All right, good. Yeah, norm. I love it because that's bigger than.
Bigger than 30.
Greater than 30, kick ass, which is what chicken, lettuce, tomato says. Right? I mean, central limit there it is. Right. So I know it's going to be normal. I don't know what this is. So over in this equation, I can't use that. What's my next best guess is this dude. So I'm going to have to use X bar in that equation. And what I want to do, so I'm going to assume that that's close to the middle, because that's what a good random sample should end up being. It should be close to the middle. So if I go so much out, how far out do I have to go? Let me say it like this. Let me do it like this. That is my sample mean. The real mean is somewhere here, right? Maybe it's here, maybe it's over there. It could be anywhere. But how far away from this do I have to go until I catch 90% of the data? Well, we figured that out a minute ago, right? It's down 1.645 and up 1.645. Stay with me. So let me say this again, what I just said. I think I said this word, maybe I didn't. If I go 1.645 up and 1.645 down, I'm going to catch 90% of the data. So how certain, how confident am I that I catch a specific data point? So sort of like, I don't like fish. I don't like fish. I don't. But I use this example anyway. If I go to this lake and I throw a net out and I catch 90% of the fish in that lake. Number one, everybody else fishing is going to hate me. But number two, how certain am I that I caught a certain fish? How confident am I that I caught a certain fish? What's the probability that I caught a certain fish? Again, let me say at the beginning again. I throw a net out that's so big that it catches 90% of the fish. What's the probability that I caught a certain fish?
90%.
90%, of course, right? Doesn't that make sense? If I catch 90% of everything, I'm 90% certain, I'm 90% confident that I caught a certain fish. In this problem, what is it we're trying to catch? We're trying to catch the real mean. I don't know what the hell the real mean is, and I don't have time to measure all the 40,000 people on this island, and they don't really know what to make of me, so they're only going to deal with me for so long. So what's the next best thing I can do? I can find my best guess from a sample of people before they start getting upset at me. And then I can do this. I can make an interval around my best guess. I can go up and down 1.645 steps. So what I'm going to do is I'm going to use this formula. Instead of, I can't use this because I don't know what the shit that is. So I use my best guess, give or take Z. And of course, the standard deviation has to change because I took a sample to figure that out. So don't forget this did start from this equation. This was built off of this equation to this to this. That's going to become important very soon. For now, you can go in. So what's this going to look like? So 62 is my best guess. Here's how I say this. The average height of people on this island is 62 inches, give or take this, 1.645. Why is this 1.645? Because I wanted to be 90% confident. So if I wanted to be more confident, I would have to go further out. These would be bigger. That kind of makes sense. If you want to be more confident that you caught a specific thing, you're going to make your net bigger. You're going to make your interval bigger. Your z-score is going to get bigger. Okay. So that's 1.645 times 2.98 divided by the square root of 189. Dude. So what I always do is I calculate this part first. And the name for this part, what this part is called, is the error. Which kind of makes sense. It's 62, give or take this. That is how much I think I'm off by. That is the error, or error. So I would plug all that shit in the calculator, figure out what that is first. What do you guys get for that piece?
$67.52.
No.
I got 0.356.
Oh, we're running out of space.
5.7 yet.
3.57.
Not sure what happened. Did you include this? Oh. Did you include the 62 when you did that? Whoever said the other thing? I don't know what happened. So I'm just doing this piece. So if you do 1.645 times 2.98 divided by square root of 189, you should get 357. So what that tells me is that I am 90% confident that I'm off by at most this much in the height. So now you just add and subtract. So 62 minus this will be 61.643. And 62 plus this. This is a much better thing to tell people. I mean, think about it. If somebody said, how many people are coming tomorrow to the thing? And I'm like, 62, I think. And that's where I stop. That's not if somebody says, how many people do you think is coming tomorrow? 62, maybe 40 to 80. Or I say somewhere between 58 and 65. It's like, all right, that second one shows me that you're more confident about what you're saying, that you're, not that you're more confident, but that your error, the amount you think you're off by is smaller. Does that make any sense? I mean, it's sort of like you call the cable guy up and you're like, what time are you going to be over? Around 3, anywhere between 8 a.m. and 9 p.m. Thanks, dude. Thanks, really, thanks. So you're saying that the error of the time you'll be here is big. I'd much rather them say we'll be there somewhere between 2:45 and 3:15. That's never going to happen. You guys kind of with me? So just giving me an average, we've always known that's not enough. But now we're starting to realize standard deviation is not enough either by itself. This improves on this. This is my best guess for what the mean is, but this communicates to people how far off I think I am with this. This is really damn good. Holy shit, that's tight, right? There's a narrow interval. It's not very big. All right, you guys doing okay out there? I know this is really freaky shit. So let's do this. Let me think. How do I want to do this? Yeah, let's do one more example up here, and then I'll go to the handout that I've got. So everybody got this stuff here? Oh, hold on. What are you getting? Times 2.98 divided by square root of 189. So somebody's getting 0.1398. What would you have done? Did you forget to square roots? No. You got a smaller thing. What would you have done? Two people did the same thing? That's interesting to me. I don't know. I'd have to see what you actually plugged in your calculator. The fact that you both got the same mistake tells me it's the same type of, what would it be?
I can show you. I put the same thing.
Oh,
Yeah.
I think they're not putting a 1. I think it's.
Keep it right there. Hold on. Stop. Stop. Let me pin your screen to my screen. Hold on. Yeah, remove. Okay. Just keep it right there. Oh, you put 0.645. It's 1.645.
Oh, I see. Okay.
Okay.
Thank you.
All right. Let's see how I come back to this now. There I am, and there I am. Hey, it's me again. Yay. Okay. Is that all right? Did the other person understand that? It was Sam. Yeah, so it's not 0.645, it's 1.645, right? That's all.
Yeah, but it looks like it's with the square, looks like with the line, looks like it's a 0 point.
I'm sorry.
Yeah, there we go.
Yeah, 1.645 from this, right? You have to go out that far to get 90% of the data. I like it. Okay. I'm going to take this away. Everybody should have this now. By the way, some of you guys, so this formula now is our first confidence interval formula. So this is a confidence interval. Good Lord, Jeff. For a population mean sigma known. My God, it's a long title. Because the other thing that isn't always true is we don't always know what that is. We don't always know what the population standard deviation is. That's section 8.2. Section 8.1 is if we're in a situation where we actually know what that is. All right, maybe. So let's do one more example problem. So let's say, take a sample of 78 gophers. Where'd gophers come from? I don't know. And find an average, sure, why not, Jeff? Tooth size of, what do you got, buddy? You're making this shit up. This is true, I know, 0.98 centimeters. Yeah. It is known. You got no room to do work now, Jeff. I know that the standard deviation is 0.27. Okay, I'm gonna let you guys write that down, or whatever you do when you do these things. Take a sample of 78 gophers and find an average tooth size, tooth length, I guess, of 0.98 centimeters. We happen to know that the standard deviation is 0.27. So we're curious about these gophers. So gophers in the whole of the United States. There's my United States. You like it? And we're curious about the gophers in this region. We're like, I think they have bigger teeth. And we have some grant money. Let's do a study. Let's use some money. Yay. So we take 78 gophers and we take their tooth size. All right, whatever. So now I want to create an interval for the actual population. This is just a sample of gophers. This is just a sample. I want to use that to get a feel for what the actual population mean is. So do I have everything I need for this formula yet? What am I missing to use that formula? What have I not told you yet? So what's 78?
The end.
I like it, this end. Where am I at? 0.98 is X bar. Obviously that's sigma. So I'm just missing Z, right? I need to know what the Z is. And that will always be determined by how confident they want you to be. They will tell you what level of confidence to construct this interval from. So I will do that now. If this is missing, you couldn't do shit. Construct a 99% confidence interval. Confidence intervals will forevermore be CI. So can you guys take a minute and figure out what the Z-score will be for this? I'm gonna delete this up here so I can make some room. It'll help you out a little bit. Can you figure out what the Z-score will be? Don't say it out loud. Give everybody a minute. And so this makes a lot of sense. It's just how far do I have to go to catch 99%? Because then of course that would be 99% confidence that I caught the real mean. If I'm 99% confident that I caught all this stuff, then I'm 99% confident that I caught the real mean. All right, does somebody know what the Z-score is? What would this be? How much area is that?
0.01.
No. 1% total outside. So how much is going to be just on that side?
0.005.
Yeah. like it. So if you look that up, so what do you guys get when you try to find that in the body of the Z-score chart? It's going to be another special situation.
Negative 2.575.
Yes. Does anyone need help finding this?
Yes.
Is everybody? Sorry. Yes.
Yeah, I need help finding that.
Okay. Let me see. Where are my Z-score charts? Where are my Z-score charts? There you are. Come here. Where'd you go? All right, let me share this. All right, so if I look at 0.0, not this one, not that one. I need 0.005. So 005, right there. See where it's right where the asterisk is? So if I follow the arrow down, I get 2575 because it's right in between 2577. Where am I at? Yeah, 2577 and 2578. So it's 2575. They split the difference. I want to show you also, if you look at your positive Z-score chart, look at the very bottom, look right down here. I call this the baby chart. Right, the bottom right-hand corner of your positive chart. Do you see how it's the confidence level? Look at the confidence level of 0.99. They call it a critical value. It's just the Z-score. Isn't that 2.575? Kabam, kabam. So you know I'm going to ask you to make a 96% confidence interval, something that's not on this little baby chart. So then you have to do it the way we just did it. All right. Is that cool with everybody? You guys good? So again, all that step is, so I want all this to make sense. I want to be 99% confident when I create this interval. So how much stuff do I want this interval to catch? 99% of the stuff, because then I'm 99% confident I caught the real mean. All right, so how far do I have to go out to catch 99% of the stuff? Oh, I got to go out this far to catch 99% of the stuff. Okay, so go do it. Go start at the mean and go up and down that many standard deviations. That's what that means. That's how it all comes together. Come together right now. Won't you please? All right, here we go. So if we do the formula, X bar is 0.98. You have enough room for this, Jeff? I don't think so. Dadgummit. All right, I'm gonna take this away. We put down here, we got Z is 2.575. By the way, I should have left that up there, but when I look up the Z-score, don't put the negative because the plus and minus is already built in. So what number do you put here? Just the pure number, because the plus and minus of both sides is built in. And that always freaks people out if you put a negative number in there and you're like, what the hell? So it's X bar, give or take, this many standard deviations, which is the old standard deviation divided by the square root of, what was it, 70. So I would highly recommend, I highly recommend that you calculate the error first. And then you can add and subtract it. So let's see what this is. This is neat. 2.575. 78. Funkadelic. Where'd it go? There it is. So I'll tell you this, your error, make sure that your error is always at least one more decimal place than this. All right, so now you do 0.98 minus this and 0.98 plus this. Can you do that in your head, Jeff? Sure, 0.952, is that right? Did you start off okay, Jeff? And then 1.0, whoops, let's say 1.008. Is that right? Yes, it's got to be right. All right, now here comes the part that I've been saving because it's everybody's favorite part. And you know that that is me not being honest. You have to write what ends up being a long sentence explaining what the hell you just found, because this is just numbers. This doesn't mean shit. So here it comes. Any questions on what we did up there?
I got a different number for my
Yeah, me too.
error.
Yeah, I got a different number for the error too.
Yeah, I did too.
0.02. Which, oh, for the error? Oh, let me see. What did I do? Oh, I see what I did wrong. Jeff. Oh, holy shit. I did a bunch of shit wrong. Sorry, guys. Oh, I love that. This is a good learning experience. Don't just assume I do everything right. What I did was I typed the new thing on the end of an old thing, so it did the whole thing anyway. So yeah, you're right. This is supposed to be what?
0.079.
Yes, thank you.
Yes.
Should have
there
asked.
we go.
So now we're gonna make. Yeah, please, dear God, call me out. I'm not gonna make this mistake all the time, but it will happen sometimes because again, if you prick me, I'll bleed. I'm a human being. So let me see if I can do this part. Now I don't know if I should trust myself at all. 0.901 up to let's see, 1.059. I think that's right.
Yes.
Okay. So I can do it on my head. I just can't put it in the calculator apparently. Oh well. So here we go. We're not done with this problem. This problem is not done. So remember, this was gopher tooth sizes. Of course. Like, what are you going to talk about today? More than likely, we're going to talk about the tooth lengths of gophers. Oh, okay. So here is the sentence you must write. We are farmers. No, we are 99% confident that the interval 0.901, what was it, centimeters, right? Yes. But the interval 0.901 centimeters to 1.059 centimeters contains true mean length of gopher teeth. Yeah, bodacious. So I think, all right, I'll let you finish writing that. Keep writing that. I'm going to think out loud for a minute. I think I'm going to show you which order do I want to do this. Okay.
Question.
Go ahead. Yeah.
For true mean length, can we just put the symbol for population mean and then, or do you want us to write it all out like that? like the mu?
Oh, yeah, because this true really means population. So you're just asking, can you just use the symbol mu?
Yes.
No, use words, yeah. And be really careful. All right, don't forget units, right? Don't forget units. And always bring back what physically the problem is talking about. I mean, putting a mu here, yeah, no, that's all right. Use words, yeah. This would be something we would write in like a article or a journal about our findings. Okay. All right. So everybody got this? Anybody not got this? And by the way, Frida, you're fine. I said at least one more place than this. So you went 2 more places than this. So you're fine. Yeah. Okay. I'm going to take all this away, especially in my United States. It's got me very concerned about myself. So real quick, when I come out there, before I've taken any samples of gophers, there is a true mean length of the gopher teeth, right? There just is. There is. All the gophers, there exists a mean length of their teeth. I take a sample and find a sample mean somewhere. It almost definitely won't equal this, right? Wouldn't you be really, really freaked out if you took a sample of Gross 1 students and their average age was equal to the average age of all Gross 1 students? That would be pretty freaky. I do expect it to be close, but not equal. Then what we do is we create an interval around this, right? And this is the error, minus the error plus the error. And what we're hoping is that we catch the real mean. So that's why I say it the way I do. You got to be real careful. You will lose points if you don't say the sentence at the end correctly. We are such and so confident that the interval we created catches the real mean. So somebody else could take a different sample, make a confidence interval, and they actually don't catch this. Because maybe their sample mean was way too big. So what the hell does that mean? What's that 99% really mean? It means that 99% of all the intervals that could be made would contain the real mean. So 1% of the time, somebody's going to make an interval and it won't contain the real mean. That is what that actually technically means. Okay. So you could do the whole problem correct, make your interval, and it actually doesn't contain the real mean. That's just freaking life. That's why I love statistics. That's why some people hate statistics. But stats is the most honest math. It says you can do everything right, but this is life, dude. You could still end up being wrong too damn bad. Because we don't know. We don't know where this dude is. No idea. So of course we could be wrong sometimes, even if we do everything right. It's built in. There's a 1% chance we're wrong. That's better than normal for me. So I'm okay with that. All right. Other thing I want to show you. This is something else that I am just realizing I wanted to do. And this is, I'm going to do it live with you guys to see what we get. I'm excited and terrified. Let's see what happens. So what I like to do is I like to go to Google, type in the word study, and give it like a week. So we get these recent studies that have been done. I don't want to think about COVID. Everything's about flipping COVID. Is everything about COVID? I'm so tired of it. All right, so there's Eli Lilly COVID. Everything is COVID. Every freaking thing is COVID. Okay, fine. Fine. Excess, yeah, here we go. This is interesting. Let's see what this is. Give me a minute, guys. This is happening as this is just happening right now. Let me see if they give me enough information. Here we go. We're getting some good shit. Let's see. How good is this shit we're gonna get? Let's see. Not good enough. Damn you. Damn you to hell. I can always go to my backup. I'm gonna try one more of these. I do have a backup that always works. I need an actual, oh my God. Should I give it a month maybe? Let me give it a month. COVID. Guess what? COVID. Hey, what do you know? It's COVID. That makes sense. I do want a lot of people studying the shit out of this, so I will take back what I'm saying. I want to see a lot of studies about freaking COVID. Get this shit done. Okay, deep phenotyping. You want to do some deep phenotyping? Yes, you do. Let's see if this gives me what I want. Come on, you can do it. You little jackass, come on. You know you wanted. All right. No. Damn you to hell. All right. I'm gonna have to go to my backup. What I'm trying to look for is, this is kind of surprising. When you get a statistical analysis, one of the first things they normally do, I'm curious about remdesivir. One of the first things they normally do is calculate, here we go. Bing, bing, bing. Look right here. So I like this because I'm always curious if anybody thinks I'm just some insane dude who's pretending to be your teacher and just making shit up. But you can see, still could be true. In this journal article, which journal are we in? Oh, the New England Journal of Medicine, dude. All right. They are using these confidence intervals. So this is those who received remdesivir had a median recovery time of 10 days. So it's anywhere from 9 to 11. They're 95% confident that the population will have anywhere from 9 to 11 days to recover. You guys with me? So you can now read a larger portion of any statistical analysis in a journal, and more of it will make sense, is my hope. So you can see some other confidence intervals down here. They're sprinkled. They're normally sprinkled all throughout statistical. Let me see if they have the other piece of this. Statistical analysis. Just out of curiosity. That's fine. That's fine. I'm just happy I found a freaking confidence interval. There's some more confidence intervals down here. Yeah, okay. So they're a common occurrence in articles because that gives people an idea. If they just said 1.99, that's not good enough. I need to know the confidence interval because that's a quick way to tell me how close to 1.09 the population would be. So if you just say 1.09, I have no idea what that really means. Is that 1.08 to 1.10? Or is that, in this case, 0.76 to 1.57? That's a broader range. Are you guys getting that? No? So I might as well show you what my backup was going to be. Good old Gallup. Good old Gallup. Do I have a link for that? I don't know. I need your news, Gallup. I hate when you did this shit. Where's the news, Gallup? News, thank you. All right, let's look at, who gives a shit? Let's see, what do they got out here? Oh my God, more about COVID, sorry. Let's do, what are you guys interested in? Economy, sure. Let's talk about, yeah, everybody, you're all curious about retirement. I know. You're all getting kind of old. Let me see. Oh shit, none of this is what I want here. Dadgummit, here we go. Sure, US investors more confident about retirement finances. Yes, go for teeth and retirement finances summarizes today. So they give you, the data, whoop-de-doo, who gives a shit. But down here, they tell me, you better tell me, Gallup, here we go, survey methods. So they tell me how many people they talked to. They tell me how they collected the data. And they also tell me For results based on the total sample of investors, the margin of sampling error is plus or minus 4. That's the error at the 95% confidence flip-in level. So 95% confidence is the most commonly used confidence level. It's just kind of accepted to be that way. Why does that make sense? Do you remember how many steps out do I catch 95% of the data in a normal curve? Does anybody remember?
2.
2 steps. I love it. 2 steps out, right? And remember, where did unusual start?
After 2.
After 2.
So it's kind of broadly accepted that 95% is where the usual stuff happens. So anything outside of there is unusual. So that's why it's the most commonly used percentage for a few different things, but for confidence levels for sure. That doesn't mean you're not going to ever see a 90% or 99% or whatever. Just depends. Okay. Oof. So let me switch over to Canvas real quick. What time we got? Okay. I think I'm just going to show this to you, and we'll work on it next time. Just because I want to give myself an early day today, so you guys can enjoy that also. So next time we'll do this. I've got up here something about dolphins, the length of dolphins. Don't ask me why. We still have to talk about part C down here. I'm not going to worry about that yet. This is section 8.1. What I do when I teach chapter 8 is I skip section 8.2 because section 8.3 still uses the z-score chart. Section 8.2 is going to use a different chart, kids. Oh yeah. So I'm gonna have to post a new chart when we get into section 8.2. So I kind of skip 8.2 for a minute so we can still use the z-score chart for a while. All right. Oh, I got a chat. Dadgummit. Will you be putting a practice quiz? Oh, I can. Can somebody email me right now and remind me? Wait, what do you mean for? It'll be chapter 7 quiz, you mean? We just did chapter 6 quiz, yeah. Can somebody email me and remind me about a practice quiz, because to remind you guys, well, let's take a look at this real quick. So currently our quiz on chapter 7 is supposed to happen on the 19th. Yeah, I don't see any reason why it shouldn't stay there. Yeah, I like it. So if somebody will email me and remind me, I can post a practice quiz up on Canvas sometime between now and this weekend or over the weekend. You guys with me? Okay. All right. Y'all look like I feel. You're like, Gophers. All right. All right, I agree. That's enough. That's officially enough. So if somebody reminds me, I could do that. Yes. If nobody reminds me, you never know what you're going to get. All right, that's enough. That's the end of class. If you need to hang out and ask me something or whatever, let me know. Ooch.
Mr. Waller.
Yes.
So what did you want me to do?
Who's
I
talking?
sent you Santana. I sent you an email and it shows like there's kind of like a glitch, I think it is, because it doesn't fully submit what I had to submit all the time. And I sent you an email of the photo. It like gets to a certain point of submitting, and then it doesn't go past that.
All right, let me double check on my side if I see any. Let's see. Yeah, it looks like no. Let's see anything. So
Did you see the email I sent you?
I did, but that's not going to do anything for anybody.
Right, but that was just trying to show you
Yeah, I know.
kind of like what the error or what the problem is.
I understand. So from now on, you're going to need to, once you submit it to Canvas, you can actually look at it. So you want to make sure that it's in there. And you can always submit it to Canvas and then email it to me also. So as a backup, just to make sure I've got it one way or the other. But what we're
Right.
going to have to do about the quizzes where this happened to you is I'm going to have to create a makeup quiz for you.
Yeah.
You're going to have to remind me to do that. Let me see. And you said it happened to you a few times?
Well, this is what happened, and I want to say it was either quiz 1 or quiz 2, and I ended up, like you said, sending to you through the email, but the problem this time is I thought it submitted, so I
Okay.
didn't send the backup to you.
I see. All right. So I can create a makeup quiz if you remind me to do that. And I can let you know when it's ready. And in the future, like I said, just be sure to send it to me both ways, just to be sure.
All right,
I really have no idea why it's doing that to you, buddy. I'm sorry.
I'll send you an email. Thank you.
Sure. You guys all right? Otherwise, everybody out there, if you're out there, I'm going to head out. Bye. If you're there.